Welcome, everybody. Thanks for joining. We've got quite an important and interesting topic coming up. We're going to talk about how we improve mission-critical services and enable them with 5G, programmable 5G networks, data, and AI. My name is Mikko Jarva. I head portfolio and architecture in Nokia's API business, and my mission is to transform how the networks are consumed and how entirely new type of applications become possible in the programmable networks.
And hey everyone, my name is Eric Wong. I'm an AI ML architect for Snowflake. I've been working side by side with Nokia to build out our services on this platform.
So we're going to talk a little bit about what problems we are solving with the solution that we're going to be talking about. Then we'll look into our solutions and partnership with Snowflake. Then we'll look into real world use cases which can be optimized and make better with the programmable 5G networks, data, and AI. And then we'll discuss a little bit about looking ahead, what's next that we're doing, what we're going to do with AI, data analytics on our platform, and so forth. So let's look into some challenges that we're looking to solve. If you think about the networks, I don't know how many of you work with the worlds of the networks, mobile networks. Anybody involved in that? Or you're just otherwise interested to hear about this topic? Yeah? Okay, so well, I work with the networks, and if you think about how the applications utilize networks nowadays, they use them over the top. That means that the application has very little control of the network and it has very little awareness of the network. But we think it should be the other way around. It should be possible for the applications to shape the network, have very strong awareness from the network, get information from the network, get information about the network sees and senses, and then optimize the network for the applications. And we think that this is necessary because the applications that require this shaping and awareness of the network are emerging, and they have very, very different kind of requirements for the networks. We'll be talking about those applications in our talk today. But especially in the era of AI, there will be lots more data created. There'll be lots more data which needs to be quickly sent for inference at wherever the models are run, whatever the inference is run. There will be lots more data that needs to be collected and uploaded for training purposes. So that's one example of how the applications are shaping the needs for the network. Now, if we can make the network programmable and part of the applications, we enable new innovations and experiences. We enable better and more secure applications. And then, of course, the telecommunication industry and network providers will profit as well from optimized use and monetization of the network. Now, if we think about the applications that are emerging, which will have and already have different kind of demands for the networks, good example is robotaxis. This is an incident that was widely publicized, and it was one of the incidents that also led then into cruise robotaxis losing their operational license in San Francisco. The taxis, they sometimes require some remote assistance from the agents, and that's when they can infer the scene and make the decision what to do next safely. Now, when they do that, obviously, the remote agent needs to be connected to that car and have the same awareness that the car has. But what if the network is congested or there's no coverage or there is some other issue? In this case, the network was congested, and because of that, the cars were not able to communicate with the remote agents were not able to support it, and then the next safest thing for the cars to do is to do nothing. So then they sit there in the traffic and block it and create a traffic jam and that kind of things. Now, of course, we can see the autonomous cars driving around here in San Francisco, and they're doing pretty well. This doesn't happen all the time. But these cars, they have also other reasons to have good connectivity. They need to know where they're going next, which ride to pick up next. They need to stream also music for their passengers and enable safe communication with the riders and the operators if needed. The other problem, what we're trying to solve here, the first one was to enable this next generation of the application that have different kind of demands from the network. The other problem we're looking to solve here is how do we make these network capabilities easily consumable, programmable? And our mission and my mission is really to bring these capabilities to easy programmability. As easy it is to build all algorithms and data analysis and load data into Snowflake, it should be as easy also then communicate with the network and make sure that the network supports the application in any way. And then I give it to Arik to tell more about problems that we solve.
Yeah, so there's a third problem domain in this, which is how do we supply the data necessary to inform these programmatic capabilities that we're building as a part of Network as Code. And the reason it's a challenge is because the problem domain or the data domain isn't confined to just first-party data from Nokia. There's a lot of great data that's present exactly like at the OEM equipment level, but also there's a lot of data that can be used to contextualize that information, such as data directly from the telecommunication service providers that are out there, which may encompass a wide variety of equipment outside of just Nokia itself. There's also the opportunity to contextualize the Nokia first-party data with things like footfall traffic to understand what is the network congestion in a particular area at a particular time, or things like geospatial data, which can help us understand, are there possible vectors of interference that could exist in various locations, such as mountains, tall buildings, high building density. And so there's also this other problem that needs to be solved within this problem domain of bringing all the relevant data into one place, which means that what was required to underpin Network as Code is a data foundation that's highly flexible, that allows for all different data types to be ingested in that platform, to be able to scale the compute required to perform any workload on all that data in a performant way. And so enter Snowflake to help solve that problem.
All right, so next we're talking about the solutions that help solve these problems. First of all, how to enable network applications with network control and awareness, how to make the network control awareness very easy to integrate by the application developers, and how to bring the relevant data into the use of the application so they can be better optimized. We have built, released, and made already available Network as Code platform. And why we call it Network as Code, we want the application developers to be certain, comfortable, and having a very easy journey to integrate network capabilities directly into the application code. So part of the network lives actually within the application and is able to control and get awareness of the network. What we do in our platform, we solve the problem of communicating with all the service provider networks. If you are here in US, think about T-Mobile, Verizon, AT&T, with Network as Code platform, you can communicate with all those networks and ensure that they perform the best for your application and you have the awareness into it. Currently, Network as Code offers a rich set of capabilities for app developers. The app developers can use tailored network performance, which enables the application to request quality of service on demand. This is lower latency, higher bandwidth, or special kind of performance from the network on demand for the application and device purposes. We'll see later on how that works. There is also capabilities to use specialized networks. Somebody who's from the network or communication industry might heard something about network slices. They are the superhighways in the network, which can be provided for specific services for higher performance. So that's what the specialized networks are available. We provide data about the network, those we call network insights, network congestion, whether network is congested in a specific area. So that area could be then avoided for these missions. For example, self-driving, whether there is a large population density that actually can be seen from the network because everybody has a mobile and they are carrying it, so we can actually track location and location of crowds from the network data as well. And then network over route optimization, that's one of the use cases we'll be talking today, and that enables optimizing missions of robot taxis and beyond the visual line of sight drones so that they can take the optimal route and ensure that there's always good network performance to support their operations. And then we provide APIs or capabilities also which enable the application get insights about the connected devices, as well as then enable safe identity verification, reduction of SIM swap fraud, and other kind of capabilities. And we already have a ecosystem that we built around our platform, including the service providers who we integrated into our network platform, the ecosystem partners who are consuming capabilities from the platform within the application, as well as then our platform partners like Snowflake. And then we're going to go to the real world use cases. So with Network as Code platform, it's been very important for us to showcase the value creation and problem solving through innovative use cases. So if you can program the network and make it work for your application, what kind of new services become possible? It can promote the safer operations and work. For example, in a port of Antwerp, we will showcase how ships can be piloted remotely. So a ship has obviously the captain of the ship, which is always on board of the ship. But then in many of the harbors, you have a pilot captain, which helps to moor the ship through the waters of that harbor, because they know it very inside out how the waters in the harbor are. So what we enable with the network specialization is the ability for these pilot captains to remotely help the captain of the ship and moor them. We're going to talk about autonomous and remote mobility and our solutions for that later on. We also enable better and more secure experiences. We can eliminate two-factor authentication using short SMS, and then enable silent network-based verification of subscriptions. And then the other use case where network APIs enable better operations are safe drone operations remotely. We've showcased how we can do cross-continent operations of drones utilizing mobile networks. So the operations team doesn't have to be there in the vicinity of the drone if there can be a compliant solution supported by the network to support the operations of drones. All right, so I already explained this use case, so I'm not going to explain it again unless somebody wants to ask a question later on. I can tell more about it. But quickly on the port of Antwerp, we use specialized network, which are network slices, quality of service and demand, and device location APIs to enhance the remote operation by the pilot captains. Now, remember we discussed about this incident where the robotaxis blocked the traffic in San Francisco because they were not able to get support remotely because the network was congested and there was no specialization in the network APIs in use. Actually, we know by now that all these robotaxis companies, while the cars are 99% of the time they are autonomous and they don't require assistance, there are occasions where they use remote agent support, human agent support to help the car navigate problems. This is a view from Zoox, which is another provider of technology for autonomous car services. And this is the remote controlling view of the agent, where the agent can help the car around obstacles remotely. Obviously, for the agent, human agent, to be able to do that, they need to have very good connectivity and awareness of the data and the situation where the car is. And we have collaborated with the technology provider called Elmo. It's active in Scandinavia, in Finland and Estonia, but their cars are also used, and the technology is used in Ukraine to provide safe remote operations of cars. And here we're going to see how the cars can be safely remotely controlled and operated some of the time when the autonomy is not controlling the cars fully. And then we can optimize the network to support this operation. So we have a few videos in here. So here is a video of the car being remotely driven from a console which looks like almost like a gaming console, right? It's, by the way, a very weird experience driving this car remotely. You know, there's a real physical car, and then you are kind of having this game-like interface to do it. Now, what happened in the video that the video stream started congested, and that is because of the network get congested, and then the remote driver didn't have a great experience about it. So what we do in the next video, we will show that we will request from our platform quality of service and demand, which will mitigate the congestion. And then in the next video, we will see how the performance of the car and the video becomes crystal clear again. And that happened truly on demand in real time. We perform optimization of the network so that it can support the remote driving operations. So that's one example of how we can enhance the remote driving experiences by providing network specialization on the demand. But of course, we would like to do this proactively. So we like to do this proactively so that the remote driving or self-driving or drone operations will not get into a trouble because there is a network congestion or no coverage or so on. So for that, we implemented use case together with the Snowflake, and that use case is about network over route optimization. So the purpose of the use case is that we can have a drone operator, we can have a robotaxi operator, or some other service that requires strong remote presence and is taking a mobility route. So that operator, let's say it's a self-driving car operator, can take a ride of according few routes. So there are few options for the route. Now, what we built an API and then algorithms that Arik will talk about that enable these drone or car operators to submit routes into our service, and then the return of the service is the most optimized route that minimizes any issues on the route. For example, there will be no network congestion, there will be the best coverage available, and then there can be also avoidance of the crowd. So that even proactively, we can avoid fully the situation where a self-driving, remote driving car or drone operation needs to be canceled or get interrupted because of the network coverage. But I'll hand it over to Arik to talk more about how did we do this implementation.
Perfect. So yeah, let's get into the nuts and bolts of how we put this demo/POC together and how and why our customers are finding early value in what we're delivering. So what we've done is we basically ingested data that represents a CSP, a telecommunication service provider's network quality map over a geolocation. What we're then doing is we're bringing in live data on footfall traffic via the Snowflake marketplace and the collaboration capabilities that exist there. The final data set that we're bringing in is on geospatial data that represents our no-fly areas. Where are there tall buildings that potentially a drone could crash into if they flew into that? With those three data sets, we then have a great kind of backbone data set to apply an ML algorithm on top of in order to help us plan the optimal route, to pre-plan, to proactively plan, to Mikko's earlier point, the ideal path for a drone to take from starting location to destination. When we talk about what is optimal, it is the most direct path while avoiding the no-fly zones that has optimal network quality. So that's kind of what we're optimizing for in this algorithm. You can see, we've got the output of that here, where we've got a heat map showing the kind of ideal route. And we'll get to a full demo. So here are some high-level details about the demo that we're going to see in just a second. What we've put together is an environment that helps us simulate an API call that would be made from a drone or from another autonomous vehicle that's going to travel from point to point. We're going to be able to specify the starting location and the destination. From there, make a call to the network as code backend, and then make a determination on what the ideal route is going to look like. A couple things to be aware of as we look at the demo. One is the speed of the prediction, how fast we can return, because even though we're pre-planning the route, we don't want it to take a really long time. We want it to process quickly. And then, how well we're able to deliver on the result which is, again, optimizing for the most direct path, avoiding the no-fly zones, and avoiding and optimizing for network quality. So we'll see a quick demo here. The demo scenario is we're going to be sending a drone from a drone hub location to a supermarket to pick up some food. And then we're going to send the drone again from that supermarket location to a Snowflake office. So here you can see we've specified the drone hub, specified the destination, which is the supermarket, and now we've generated quickly the ideal path. And again, what we've done behind the scenes is we've done all the joining of those different data sets. We've applied an ML algorithm called A star, and that's helped us to predict what the optimal path would be from location to location. This is going to go for one more location. It's going to switch from the Asian supermarket over to the Snowflake office. And you can see, maybe you'll have briefly saw in the previous, as we were looking down there, that we avoided all the no-fly zones, which are denoted by the red locations, demarcated by the red locations. So we'll see it run again. And same type of thing, it's going to predict our ideal path in green and avoid those no-fly locations in red. So that's a quick demo of what we've put together for drone operators. So wanted to also overview the timeline of us ideating and working together on this problem. The whole thing started with a kind of germinated seed at MWC in 2024, where Nokia stopped by our booth and realized that Snowflake is much more than just a data warehouse at this point. We can perform geospatial analytics. We can do advanced ML, predictive algorithms within Snowflake. We can make API calls and return them very quickly. So a kind of inflection point occurred beyond that initial germination phase, where Nokia had acquired a company called Rapid API. This is all public knowledge. And they were an existing Snowflake customer, so they kind of became a Snowflake customer by default. And then we started early collaboration there. But really the turning point came when autonomous vehicles became a priority project for Nokia. And they kind of thought back to what they saw at MWC, and they came to us to understand more about what the solution could look like for us to put together collaboratively. So over the course of a couple weeks, we put together an architecture and it was deployed, and it actually ended up going out as a demo to MWC, the latest MWC in 2025. So really proud of the collaboration that happened here and just how quickly we were able to iterate once we had the platform available to work on. But that's not it, right? There's still, that was just the first of many different things that could be developed on top of Snowflake as a platform for network as code. And so looking ahead, we have been talking with Nokia about various ways that Gen AI and machine learning is being applied to telco data. Some of the obvious ones are kind of predictive network maintenance, network optimization, network equipment purchase optimization. All those sorts of things are kind of common themes to pursue with Gen AI and ML, make that a little bit more efficient. But we overall just believe that given the vast amount of quality data that Nokia has, there's a lot of future opportunity for other use cases within the platform. So I'm going to hand it over to Miko to wrap this up for us on what's kind of priority for him and his team within Network as Code.
Thanks, Eric. Yeah, so specifically for Network as Code, so hopefully you remember the platform in here that enables applications to optimize and get awareness of the network. And those applications could be like the ones controlling drone missions or the ones controlling robotaxis or so forth. And for them to execute those missions safely, always with the good connectivity and awareness of the network and the devices and so forth. So Network as Code is that platform. Now, how are we going to use AI, data and analytics going further in collaboration with Snowflake? First of all, the use case that you already see is the optimizing network for AI at the edge. So we want to be able to support the use cases that leverage AI and has large data requirements. Obviously, that data needs to be always delivered over the network. So those are very important use cases for us to enable through Network as Code platform. There could be AI inference on the network edge or as near to the devices as possible, doing heavy-duty video inference, for example. That's one of the use cases. And obviously, these self-driving cars, any connected cars, they actually might generate terabytes of data within a day, especially when they're in a data collection mode. So that data needs to be collected optimally at optimal times, and that's a very good use case for on-demand use of the network. Then for the platform itself and how to make it better, we are already implemented coding and use case assistant using generative AI. So that helps the developers to integrate and innovate new use cases utilizing the platform capabilities. And we have also very powerful APIs already in the platform, so that's a good place also bringing API agents that have all the skills of the platform APIs available and can do then aggregate tasks that combine all this. For example, the route optimization or mission optimization using the power of the network APIs. Then we also have the Rapid API Marketplace, which is, by the way, the world's largest marketplace for APIs available. So we're looking to do with Snowflake and the data that we have on Snowflake about that marketplace, optimization of that marketplace, and then discover also new use cases for API usage and value creation. So those are some of the areas where we look in the future in our collaboration with Snowflake and then in the use of data analytics and AI. Thank you.